Hello, welcome to Math. Thank you for watching today. Make sure you've got your usual supplies as always. We have a fun topic today. It's not entirely new, but it's a new way of talking about something. It's like new terminology, if you want to think of it that way. So it's definitely worth your time. So when you are ready to move on, go ahead and keep watching and we'll do our first puzzle. All right, so there it is. I'll move this out of the way just so it's not in the way. Actually, I'll just hide it. So, like we always do, pause the video, please, and figure this out on your own. And then when you are ready to, you may unpause and you can see my solution. Good luck. All right, so, like we always talk about, it's kind of like have to figure out first where to start. Where is the place that we know something that we can figure out? And we often look for the equation that has only one variable. In this case, that variable is like a fun picture, but again, that variable is like an unknown number. It's a mystery number. So, excuse me, this top equation has three variables, a cake. I think we call that lava cake, right? When it's like upside down, and then a cupcake. Here we have two variables. Here we have two, we know are the same, which is helpful, but they could be anything right now. And then this fourth one is one. Now, again, there are two, but they're the same. So it's the same variable. So I think we found our place to start right here on this fourth equation. So 20 times 5. Ooh, what is 20 times 5? Yeah, that is 100. So, and this goes well with what we're doing today. We want to find a number when we multiply it by itself gives us 100. So what number times itself is 100? Yes, that's 10. So those, what are those, moon pies? Or I don't know. You probably know what those are called. I forget. If someone told me like, oh yeah, but I forget what those are called. So those cookies are 10. So I'm going to fill that in where I see those. And now what can I figure out? Yeah, the cupcake, or at least that's what I'm calling it. Looks like a cupcake. So I know 10 minus the cupcake is 8. So what do I have to take away from 10 to leave 8? Yeah, that's 2. So the cupcake is 2. And there's one more down here. Okay. And now I have this equation in the middle. The lava cake is the same as the cupcake. So that means the lava cake is also 2. So I'm going to fill that in up there. So now all we have left is this chocolate cake. And what times 2 is 2? Well, if it's multiplying and staying the same, this has to be a 1, right? And maybe you figured that out before I did. Maybe you saw that and you didn't even have to know what those are. But if you put that together with this, like if these numbers are the same and I'm multiplying one and getting the other, well, then this has to be 1. That's great job on you if you figure that out first. Like you could figure out that the cake was 1 first. So we're going to plop that in down here. And now we have our final equation, of 10 minus 1 times 2. And what a great problem for us in 5th grade, because it reminds us of our order of operations, doesn't it? I hope you didn't subtract first. If you did, quick pause the video and fix it. Did you remember to multiply first? Because remember, please excuse, that's an E, my dear Aunt Sally, multiply before you subtract. There were no exponents or parentheses, so you still have to do your multiplication though. So this gives me 10 minus, because I didn't use a 10 yet, I haven't subtracted. I did multiply 1 and 2. So 10 minus 2 is 8. Alrighty. If you don't follow the order of operations, you end up with 10 minus 1, which is 9, and then 9 times 2 is 18. But that would be incorrect, and it would bring much sadness to us. So it does impact the answer usually if you don't do things in the proper order. So it's a good reminder for all of us. So hey, there you go. Nice job on the puzzle. It's been a while. Okay, so I have a simple, possibly random question here. It says, what do the following numbers have in common? And I've got 36, 81, 16, 25, and 1. Maybe you already know. Maybe those numbers are familiar to you. Now, obviously, they're familiar in that you know what they're called and so on and so forth. But in terms of knowing how they're all connected, because some are odd, some are even, some are single digit, some are 2-digit, and I could have put larger numbers on. I chose to just put some smaller ones. So there's more to it than just, well, I know what they are. So we're going to watch a short little video. It's less than 3 minutes. And I bet these numbers will have more in common than you maybe first realized. So let's find that video quick. There we go. So it's called square numbers. And again, maybe you've heard that before. I've said it a few times maybe, but we're going to watch this and learn more about these things called square numbers.
We're going to look at some special numbers that have particular names. These are called square numbers and cube numbers. Let's start with looking at square numbers. Here are some patterns using square tiles arranged in a square. The first picture has 1 tile. The second picture has 4 tiles. The third picture has 9 tiles. We get these numbers as follows. The first picture has 1 row and 1 column. The second picture has 2 rows and 2 columns. And the third picture has 3 rows and 3 columns. We can see that 1 times 1 equals 1. 2 times 2 equals 4. And 3 times 3 gives us 9. Any positive integer multiplied by itself is called a square number. So, the next shape in our pattern has 4 rows and 4 columns. 4 times 4 is 16. So 16 is the next square number. As this continues, we find that 5 times 5 equals 25. 6 times 6 equals 36. 7 times 7 equals 49. 8 times 8 equals 64. 9 times 9 gives us 81. And 10 times 10 equals 100. So we have now obtained all of the square numbers up to 100. Here is a list of the square numbers. Try to learn as many of them as you can. They come up in all sorts of places. We can write square numbers in a different way using indices or powers. 1 times 1 is written as 1 squared, or 1 to the power of 2. A 2 is used because there are 2 1s multiplied together. We can repeat this all the way down to 10 squared.
All right, so that was sorry about that. That was our short little video on square numbers. So these 5 are examples of numbers that are all square numbers, because I can make a square. If I had like 36 tiles that were all square tiles, I could make a square out of them. I can make a 6 by 6 square. I can make a 9 by 9 square, or a 4 by 4 square, or a 5 by 5 square, or a 1 by 1 square. And I know the narrator used a couple of different terms, which hopefully didn't throw you off too much. I love listening to other accents. I think it's so cool when I hear a new accent. So hopefully you enjoyed it too. But here are some, again, the first 6 examples of square numbers, and it would keep going. It never ends. It would just keep going and going. But when you hear somebody say like 5 squared now, and I will say that I was trying not to say it just because it wasn't a term we had used yet, but I might have said it, or 3 squared or whatever. So if you hear someone saying a number squared, what they're really talking about is it being multiplied by itself. So 5 to the second power, she said to the power of 2, same idea. We could also say is 5 squared because, again, like she showed us, you're multiplying it by itself, which you'd be able to make a square out of. You can make a 5 by 5 square. So 8 squared would be 8 to the second power. That's a terrible 2. And that would be 8 times 8. Okay, so your work today does a little bit with, just getting familiar with square numbers and squaring numbers. And so it's a little bit of that. It's a little bit of review from what we did previous, looking at our test, just seeing what were we doing well with, what do we still want to work on. So I threw in a couple problems that fall into that category of things we still want to work on. So some decimal work and some order of operations. So please check out the Google Doc first, and because that's where the questions really are nice and well written and well organized, and then you can enter your answers in the Google form. Okay, in the Google form, I've started doing a little differently. Certain parts it won't let you move on until you have the correct answer. So if it's not letting you move on, that means your answer isn't quite right, and you have to really think through that part that you're stuck on. So good luck, and thanks for watching. And if you want to do one last puzzle, I have one more to do. This isn't a have to. You can be done with the video now, but if you like them, then it's there for you to keep watching. And it's a little different one than we usually do, so maybe you'll enjoy the new twist. So take care if you're signing off, and if you're still watching, enjoy the puzzle. So there it is. Now there are almost like three puzzles on their own. So you have case 1 here, and case 2 next to it, obviously, and then case 3. So each one is its own pattern. So pause the video, take a minute to see if you can figure out what each of the patterns are for each of these 3 cases. And when you're ready, you may unpause and see my solution. Okay, so we'll start with case 1. Case 1 makes sense, right? And what I have learned to do over the years, like if there is like a number pattern in front of me, I sometimes like to see what's happening, and that can sometimes be helpful. So how do I go from 13 to 17? Well, it's going up, right? So I'm adding. And how much am I adding? Yeah, I'm adding 4. Okay. So from 17 to 22, that's also increasing. So maybe it's still adding. How much is that going up? Yeah, 5. Okay. Oh, so is this next one going to be up 6? Let's see, 22 plus 6. Yes, that is 28. Oh, all right. So by seeing the pattern, and it doesn't always work out that nicely and easily. Sometimes, it doesn't. But it's a great strategy to be able to see what's happening, because you can see either, yeah, it is working, or, oh, gosh, it's not working. Maybe I should find another way to make this happen. So this one did work for us. So I think this one we should add what? Yeah, 7. So this would be 28 plus 7, which would be 35. Okay. All right. So how about this next one, case 2? Let's see. All right. So this is going up 6. I'm going to not write the plus sign just because I don't want to get it too clunky here. And this is going up. Oh, wow. That jumped up a lot. That went up 12. Okay. And then this one went up. Oh, wow. That one went up. Let's see. Oh, wait. I think I see what's going on here. That one went up 24. Do you see what's happening? Yeah, 6 times 2 is 12. 12 times 2 is 24. So what's this next one going to go up? Yeah, it's going to go up 48. So again, hopefully you see the power and helpfulness of seeing your work, seeing your thinking. It can really help us see what's happening. So that is an 8, by the way. Sorry, that kind of looks like a 9. So 48 plus 47. Well, 40 and 40 is 80. 8 and 7 is 15. So that would be 95. All right, we're 2 for 2. And then this last one, let's see, this one went up from 1 to 4. That went up 3. And from 4 to 13, that one went up. That went up 9. Ooh, 3 and 9. Those are definitely related, connected. So, 13 to 40. Wow. Okay. Did you figure that one out? That'd be 27. Oh. Okay. I see. So 3 times 3 is 9. 9 times 3 is 27. Look at that. We can see the pattern. So what do we have to do to this next one? Yeah, we're going to have to multiply that by 3. Ooh, did you figure that out? If you haven't, go ahead and pause the video. See if you can figure it out before I do. But that would be 81. So I have to add, oops, that's a terrible 8. Sorry about that. So 81. So 81 plus 40. So that would be, let's see, 121. Nicely done. So if you took the time to do an extra puzzle and challenge yourself, I'm proud of you. Be proud of yourself. The work you put in, you'll never regret. You'll never sit there and go, golly gee, I wish I hadn't worked so hard on something. No, because it changes you. It makes you a better mathematician. It grows your brain. Well done. So have a great rest of the day. I hope to see you soon, whether it's on Zoom or in person. Take care.